Moisture in the oil and paper insulation systems is a significant concern for power transformers and can lead to unexpected failure of equipment and unplanned outages. Managing moisture is an important investment. Therefore, it is essential to fully understand these phenomena. Excessive moisture in the oil of a transformer reduces the oil's dielectric strength and introduces the opportunity for flashover and arcing. Bubbling happens when moisture held in the winding paper heats up and becomes steam that forms a void in the insulating oil. These voids have lesser dielectric strength than insulating oil. As these bubbles form, they tend to rise and accumulate. They also merge to expand the dielectric strength voids, thereby increasing the opportunity for flashover and arcing. In power transformers, moisture comes from several different sources. First, solid insulation within the transformer, both paper and pressboard. As solid insulation ages, depolymerization of paper generates moisture. Second, gaskets deteriorated by aging or improper installation provides a two-way path for oil to egress and air and moisture to ingress from the environment. Finally, broken conservator bags and non-functioning nitrogen gas blanket systems also allow ingress of air and moisture into the system. Management of moisture within a transformer is critical to aging, reliability, performance, and safety. Most utilities employ a schedule for oil sampling and subject the insulating fluid to dissolved gas analysis and moisture content testing. The Carl Fisher titration test measures the absolute moisture content in the oil and reports the parts per million content. Moisture exists in three states: dissolved, free to move between oil and paper; bound, attached to acid, fibrous particles, dust, etc.; and free water. The Carl Fisher titration test measures all three but cannot differentiate dissolved from bound water. It's important to know the amount of moisture in the oil and the amount of contaminants since the dielectric strength diminishes as contaminants increase, including bound water. Processing the oil to remove moisture and contaminants will aid in returning the oil to a higher dielectric strength for better performance. The acceptable amount of moisture is dependent on temperature, the chemical composition of the oil, and the aging level of the oil. Moisture sensors and monitors are a continuous online means for managing moisture of both insulation system components. In practice, only the relative saturation of moisture in oil can be measured, and the moisture in paper must be inferred from it, based on the water absorption characteristics of both oil and paper and time taken for the migration characteristics of water between them under variable temperature conditions. A capacitive moisture sensor measures water dissolved in oil. It measures the relative saturation, which is the ratio between actual water content dissolved in the oil and the amount of water the oil could carry at saturation and the oil temperature at the same location. Dynamic Ratings transformer monitoring products integrate moisture sensor data and other parameters as part of the moisture management model. Measured values include moisture content in oil in terms of percentage relative saturation, temperature at the moisture sensor's location, top oil temperature of the transformer, load current measured on the winding of interest, and bottom oil temperature of the transformer. In addition to moisture data, transformer characteristics such as computed winding hotspots for up to 6 windings, type of insulating fluid, the height of the oil above the hotspot, the altitude of where the transformer is located, and the type of oil preservation used are all variables in the calculation. The transformer monitor applies various rules to the data and results in a determination of the moisture in insulating paper at the winding hotspots, the bubbling temperature, water condensation temperature, the relative absolute water content in parts per million in oil, and the moisture content within the barrier. The global aging rate is also calculated to provide a daily loss of life and is added to all the previous calculations to provide an accumulated loss of life in days. This data allows operations and maintenance staff to plan ahead and take action if required. To learn more about Dynamic Ratings moisture and oil monitoring solutions, visit www.dynamicratings.com.